3 minutes ago, the silence of the cosmos broke with the discovery of a new object, C/2025 V1 Borisov, drifting between Earth and the enigmatic interstellar comet 3 I Atlas. Both objects now shine strangely bright in our skies, yet remain nearly tailless, defying expected cometary behavior and leaving experts stunned. Whether this marks the beginning of a cosmic collision, a rare celestial alignment, or something entirely unknown remains unclear. The discovery began on the night of November 2nd, 2025, when a faint, unfamiliar blur appeared in images captured at the Margot Observatory in Crimea. Gennady Borisov, the astronomer at the telescope, noticed the object moving against the fixed stars on a path slightly offset from the familiar tracks of main belt asteroids. Within hours, he reported the observation to the Central Bureau for Astronomical Telegrams, providing precise coordinates and an initial brightness estimate of magnitude 12.1, noting a diffuse coma nearly half a minute of arc across and no apparent tail. The provisional tag G signaled to the global astronomical community that something unusual had entered the field, and the name Borisov immediately drew attention. Known for discovering 2I/Borisov, the first confirmed interstellar comet in 2019, using his own homemade telescope, his new detection hinted at another extraordinary object captured by a sharp eye and custom optics. As word of the discovery spread, observatories across Russia, Japan, Ukraine, and the Canary Islands rushed to confirm the find. Digital images and brightness estimates flooded online forums and official databases. Most teams reported the same features Borisov had seen: a condensed, bright coma with no visible tail. Only 2 of the earliest 10 reports indicated a faint and inconsistent tail-like extension, details that would spark ongoing debate in the days to follow. By November 3rd, the object was added to global confirmation lists, prompting the Central Bureau to issue an alert. The provisional tag soon became the official designation C/2025 V1 Borisov, accompanied by a call for urgent follow-up observations. Amateur and professional astronomers worldwide were encouraged to collect photometry, astrometry, and any possible spectra to refine the orbit and better understand the nature of this newcomer. The pace of observations quickened as new images and measurements were posted hourly, transforming Borisov's discovery from a lone observation into an international campaign. Telescopes worldwide now focused on tracking C/2025 V1 Borisov as it traversed the sky in the apparent region between Earth and the interstellar traveler 3 I Atlas. Early archival review revealed the earliest trace of the comet in Palomar Observatory survey frames from October 29th, a faint smudge at magnitude 17.5. Over the next 5 days, the object brightened by more than 5 magnitudes, nearly a 100-fold increase in visible light. This rapid surge ignited global interest from amateur astronomers, who quickly added their own confirmations. By November 3rd, images from Sacagawea in Japan, Lviv in Ukraine, and the Astrover facility in Russia began appearing across online forums, each showing a sharply defined coma with still no clear sign of a tail. A stacked image from La Palma on November 4th measured the coma at 4.6 arcminutes across and a magnitude of 10.9, bringing the object within range of modest backyard telescopes. The nightly exchange of data grew into a ritual, with observers posting raw images, photometric measurements, and visual estimates to platforms like Cloudy Nights, COBS, and specialized Telegram groups. Results were cross-checked across continents. Observers in AO, Japan, recorded the object at magnitude 12.2 on November 2nd, while an independent team in Lviv measured it at 12.1 only hours later. By early November, a consensus had formed. The comet was brightening faster than expected, now visible to small telescopes under dark skies, and displaying a conspicuous coma that dominated every image. Reports from Sighting Spring in Australia, Cherenka Front facilities in La Palma, and smaller stations across Poland, South Africa, and Eastern Europe echoed the same observations. Most teams confirmed the absence of a tail, with only two outlier reports, one from Crimea and one from Japan, hinting at faint, inconsistent extensions that some attributed to image artifacts or background stars. The majority of stacked images reinforced the prevailing view, a bright, round coma with no obvious tail and a brightness curve that diverged sharply from initial expectations. The global response showcased the power of amateur networks, which independently confirmed the discovery from nearly every longitude within a week. Their collective contributions formed a composite timeline of the comet's rapid brightening and a detailed record of the object's evolving appearance. With the brightness surge confirmed and the coma-only morphology consistent across sites, the next challenge was to determine the orbit and understand the unusual geometry placing C/2025 V1 between 3I Atlas and Earth. By the pre-dawn hours of November 7, 2025, three comets traced separate arcs across the inner solar system. C/2025 V1 Borisov, 3I Atlas, and C/2025 K1 Atlas, each following its own orbital plane. Skyview models revealed a geometry more complex than a simple flat sky map. Although V1 Borisov and 3I Atlas appeared clustered in the constellation Virgo from Earth's vantage point, they were in reality separated by tens of millions of kilometers. V1 Borisov lay closest to Earth at roughly 55 cents, crossing upward from below the ecliptic plane. This trajectory placed it nearly between Earth and the outbound interstellar comet 3I Atlas, which remained well above the ecliptic on a hyperbolic escape path. Despite their apparent alignment in the sky, the two comets never approached each other in space. On November 7th, the projected angular separation between the pair ranged from 44 degrees to 51 degrees, depending on the observer's longitude, a gap roughly equivalent to the width of two outstretched hands held at arm's length. Meanwhile, 3I Atlas remained physically distant, approximately $1.80 from Earth at closest approach, always well outside Mars's orbit. Its apparent alignment with V1 Borisov was purely a consequence of viewing angle. Observatories in both hemispheres confirmed similar angular distances, validating that the apparent clustering was global and not a local effect. C/2025 K1 Atlas traveled a wholly different course, its steeply inclined orbit keeping it in Leo, separated by over 14 degrees from the other two and even farther in three-dimensional space. On November 7th, although V1 Borisov and K1 Atlas happened to share a similar heliocentric distance, they remained visually and physically far apart. These trajectories created a brief observational window from November 6th to 8th in which all three comets were visible before sunrise, each occupying a unique section of the sky. The alignment existed only visually. True spatial distances remained vast. Only a three-dimensional perspective reveals the scale. Three objects, three distinct orbits, and a fleeting alignment visible only in projection. Virgo dominated the southeastern sky before dawn in early November, offering a rare viewing opportunity. C/2025 V1 Borisov appeared there first, rising well ahead of the sun and holding near magnitude 13, making it reachable for backyard telescopes under dark skies. Observers were advised to scan Virgo approximately 2 hours before sunrise, where the comet's position near the celestial equator made it accessible from both hemispheres. Even small 8-inch telescopes could detect the compact coma as a soft, round glow. Under clear skies, some observers noted the coma appearing to grow slightly in size and brightness, though no tail was evident. Only a few degrees west, 3I Atlas traced a similar route through Virgo, slightly brighter at around magnitude 10, but still tailless despite periods of increased solar activity. Both comets were best viewed during the final hour before twilight, when the sky was darkest and the comets were highest above the horizon. Planetarium apps depicted V1 Borisov and 3I Atlas as a close pair, though in reality they remained separated by tens of millions of kilometers. Meanwhile, C/2025 K1 Atlas